Number 3 on the Fall 2012 final has a car starting from rest and accelerating at 6 feet per second, traveling at constant velocity, and then slowing down. Determine the total distance the car has traveled. Module 1, we worked lots of problems like this, and we usually drew some sort of time and distance graph and time and velocity graph. Alright, so let's see. We're going to determine the total distance. Let's work with velocity because that is sort of in between distance and acceleration and usually the easiest to work with. So we'll draw a velocity graph versus time. Okay, starts from rest, so we got that part. Accelerates at 6 feet per second for 8 seconds. So after 8 seconds we've got some constant acceleration, and so we will need to find that velocity. So that velocity at 8 is equal to 0, the initial velocity, plus the acceleration times time. So that velocity is 48. Then travels at a constant velocity for 19 seconds. So 8 plus 19 is 27. Okay, so we're traveling at constant velocity, then slows down at 12 feet per second, coming to a stop. Okay, I know this slope is minus 12. This slope was a positive 6. Couple different ways of determining this. We'll need to know this time. Okay, a couple different ways of determining that time. We can notice that slowing down was twice as fast as the speeding up, so it's going to take half the time. If I want to write that as an equation, I can have v equals my initial velocity minus acceleration of 12 times t, and we know our final velocity is 0. Alright, so here I can solve to get t, or delta t is equal to 4 seconds, so my total time is 31 seconds. Okay, we know that change in position is the area under velocity. So I can simply find these three areas. Okay, so area 1 is 1/2 the base times the height. Okay, that equals 4 times 48 is 192. Okay, that would be units of feet per second and seconds, so this is feet. Alright, can find area 2 here. Just a rectangle, a height 48 and a length of 19, and that value 48 times 19, 912. And in our last area, actually just going to be half of this first area. Oops. Change colors there. But I'll write it out. So 1/2 the base times the height. Okay, so then our total distance, not sure why I worked it all over there, our total distance 12 plus 96, about 1200. Again, units of feet. I could have worked this in 3 parts using constant acceleration equations. I'll just write those out real quickly. So here's an alternate way of doing it. I could have delta S. Okay, I know my initial velocity was 0. And then I know my acceleration of 6 and my time squared. Okay, 64 times 3 is 192. Okay, I know my second part. Let's see, I would have still had to calculate that velocity. It's 48, so I would have had my initial. I'll just work each one separately. So this is delta S would be my velocity, 48 times 19 plus 0t. Okay, so you can see that comes out the same. And then delta S3 would have been my initial velocity. I didn't know if I calculated my acceleration I could use this. If I didn't calculate my acceleration, there's another equation that's the average velocity. And so I could use that as 48 over 2. I still need my delta t. I could have used my acceleration equation. Let's go back and do that just to show that. Okay, we also have one as v final squared minus v initial squared over 2a. Okay, so that would have been appropriate here since we had our acceleration. 0 minus 48 squared over 2 times minus 12. Okay, so 48 squared over 24. (96), same thing. So this is an alternate way of doing it. Again, I think the graph laying things out visually is a little bit easier.